we are still on the circle theorem. We are still looking at the theorems. So we have already looked at the first two theorems, or two theorems. So we are now looking at theorem 3. So the theorem 3 is this, that angles formed or subtended by the same arc on the circumference are equal. Angles formed by the same arc on the circumference are equal. Okay, so these are illustrations. Let's look at the illustrations we have here. So we are saying that that's why, you see, if you remember, we learned before we really started this theorem, we learned about paths of a circle. So see, we are still using the paths, the key terms. If you don't know, you will not be able to understand. So this theorem says that angles formed by the same arc on the circumference are equal. So you see, this is from here to this point. This is an arc. This line along the circumference is an arc. You can also move from here to this point. This will be an arc. From here to this point is also an arc. To this point is also an arc. We can even move from here to here. It's an arc. So we are saying that angles formed by the same arc or subtended by the same arc on the circumference are equal. So you see, this angle x, angle x is what? It's formed by this arc. So we stand here, we are standing on this side, then move along this line, straight to this line, then from here we move. So we see that this angle is formed from this arc. This arc stand on this at this point, and then we move to this point, and then at the same point move this at this point. We see that this arc, the angle is formed by this arc, and then the same with this angle y. We are using the same arc, we are standing at the same point, this same point, and then we are forming this angle y. Obviously, we are forming this angle y. So what we are saying is that these angles s and y are equal. Why? Because they are formed from or by the same arc. They are formed by the same arc on the circumference. So in order for us to understand it very well, let us apply the theorem 1. Theorem 1, we learned that angle formed by an arc at the center of the circle is equal to 2 times the angle formed by the same arc on the circumference. So if you apply that theorem 1 here, you really understand it very well. So if that is the case, then we can use the same arc to form this angle at the center, angle T at the center. Have you seen? You can form this same angle T at the center. So, okay, so as we are saying, let us use the theorem. So we see that from theorem 1, this angle T is formed by this arc at the center, and then we are forming the same arc is forming this angle y and x on the circumference. But we know from theorem 1 that angle formed by an arc at the center is equal to 2 times the angle formed by the same arc on the circumference. If that is the case, then this angle T, if you want angle T, is equal to 2 times angle S, and it's the same as what? 2 times angle what? Y. So in this case, we can say that it implies that from theorem 1, T is equal to 2 times X, T is equal to 2 times X, and the same T is also equal to what? 2 times Y. So if T is equal to 2 times S, and the same T is equal to 2 times Y, then we can say that 2s is equal to 2y. We can equate this 2s and 2y. That is, we can say that 2s is equal to what? 2y. If you divide 2 by 2, you get what? S is equal to y. Have you seen? So this really proves that angles formed by the same arc on the circumference are equal. So look here. Look at this another illustration. So we are standing here. You see, this from this point to this point is what? It's an arc. Have you seen? This is an arc along this circumference. This is an arc. And then we are using this arc. This arc is forming this angle R on the circumference, this angle. And this same arc, we are standing at the same point, we are forming this angle what? This same angle what? R. So we know already that since this arc is forming this angle, and then the same arc is forming this angle on the circumference, then we are saying that from the theorem, this angle is equal to this angle. That is why if this angle is R, then this angle also has to be what? Has to be R. That is why we have named this R, and then we have also made this one R. Okay, so we are standing at this side. Let us go and stand at the top. We are standing where we have this dotted line. If you are standing here, we see that from here we are standing at this point. From this point on the circumference to this point, this is an arc. Everything. So I hope you can see that this angle T, this angle marked on this yellow, what do you call pen or ink, is what is formed by this arc. It's formed by this arc. And then this same arc is used what to form this angle. This angle here. Have you seen? So in that case, we are saying that this angle has to be equal to this angle. Why? Because this angles are formed by the same arc on the circumference. So that is why we have named this angle to be T, and this angle to also be what? Be T. So if this is T, then this is also T. Okay, let's look at another illustration. So we have another illustration. So look at this. We are looking at this illustration. So we have this arc. We have named this arc AB. I mean, this is point A, and this is our point B. So A from A to B is an arc, and then from here, if you also move from, you have a major arc. If you move from this side up to this side, that one too is an arc, but that arc is greater than this arc at the bottom here. So this one, if you divide this the two arcs, then we can see that this is a minor arc, and the other one is what is a major arc. Fine. So you see that this arc, this minor arc, is forming a lot of how many? 1, 2, 3, 4, 4 angles on the circumference. Have you seen? So we are forming this arc is forming 4 angles on the circumference. It's forming. So we are standing at this arc or at this point, and then see we are moving here. Then come here, then the same point we form this angle. We are the same point, we form this angle here, and then from the same point, this arc or the same arc, we form this angle here. From the same arc, we are forming this angle here on the circumference, and from the same arc, we are forming this angle on the circumference. From the same arc, we are forming what? This angle on the circumference, and from this same arc, we are forming what? This angle on the circumference. So, in fact, irrespective of number of angles that can be formed by the same arc on the circumference, all those angles will have to what? Will have to be the same. So that is what this theorem states. It says that angles formed by the same arc on the circumference are equal. So this angle here is equal to this angle, and then it's equal to this angle, and it's equal to what? This angle. So that is what the theorem says. It's not very difficult. When you will also look at examples after these lessons, and then you will begin to appreciate and enjoy. Thank you for watching. As I said, don't forget to subscribe to my channel. The name of the channel is Get Understanding. You have to get understanding in all your studies. You don't have to memorize. Don't get understanding, don't memorize. Because you need understanding to be able to excel. There's something to be able to excel in everything that you do in your life. Don't forget to subscribe. Thank you. And then hit the bell notification icon so that when subsequent videos are uploaded, you'll be notified. Thank you for watching, and see you in the next video. Hello students, welcome back. Yeah, so on the second theorem, so we just considered the theorem 3. We looked at theorem 3 some few minutes ago. So in this video, we are going to look at some examples on theorem 3. This same theorem 3. So theorem 3, what do you recall? What did you say about theorem 3? Theorem 3 says that angles formed on the circumference by the same arc are what? Equal. Angles formed by the same arc on the circumference are equal. So in this example, we are told that if angle ABC, so the angle is what? At B. If angle ABC is equal to 44, so what is angle ABC? ABC is equal to 44. So we are told that if this angle is what? Is 44 degrees, you find what? Angle ADC, angle ADC. You find angle ADC, this angle. Have you seen? So how can we find this angle? We have to use circuit theorem. That's why we're saying to find this angle, because there's no way you can find apart from using the theorems. So this is examples on theorem 3. And from theorem 3, we know that angles formed by the same arc on the circumference are equal. So look at this. Stand here. If you are standing at this point A, and then to point what? C. From A to C, you move along the circumference to this point. It's an arc. Have you seen? But this angle at D is formed from what? It's formed by this arc AC. Have you seen? So if you stand at D, you move to this point, and then if you stand at what? At C, you move to D. So you see that this angle ADC is formed by the arc AC, and this same arc is forming an angle of what? Forming angle what? ABC, which is given to be 44 degrees. Have you seen? So we can conclude that since angles formed by the same arc on the circumference are equal, then we can say that, and if angle ABC is given to 44 degrees, then surely angle ADC is also equal to what? 44. So it means that this angle is also equal to what? Equal to 44 degrees. So one, we can say that angle, can say that angle ADC is equal to what? 44 degrees. Why? Since angles formed since angles formed by the same arc on the circumference are equal. Angles formed by the same arc on the circumference are equal. They are equal. Fine. So let's go to number 2. Number 2, we are also told that if angle ADC, angle DAB, angle DAB we are told that if angle DAB is equal to what? 44. Angle DAB is equal to, if angle DAB is equal to 44, what is angle DAB? Angle DAB, this angle. So we are given that this angle is what? 44. Angle DAB is equal to 44 degrees. And what? Angle ABC, angle ABC is what? 60 degrees. Angle ABC, angle ABC, this angle is what? This angle is 60 degrees. We are asked to find what? You have to find angle A. You have asked to find angle what? DCB. Angle DC. What is angle DC? DCB. This angle. You have to go to find this angle. Have you seen? So what do you notice here? From here, DB is an arc. DB. If you move along the circumference, DB is what? Is an arc. And this DB is forming this angle at A. It's forming angle DA at this point at A. And this same arc DB is forming angle DCB at C. So if this angle is what? The angle DAB is equal to 44. Then angle DAC must also be equal to 44. Why? Because angle DAB and angle DCB are formed by the same arc DC. So it means that angle DCB, this angle DCB, this angle should also be equal to 44 degrees, because this angle DCB and angle DAB are formed by the same arc DB. Okay, the next one we are supposed, and then we are also asked to find angle ADC. Angle ADC. What is angle ADC? This angle. Have you seen? So what will be angle ADC? This angle. Angle ADC will also have to be 60 degrees. Why? Because angle ADC is formed by the arc AC. And then we notice that the same arc AC is forming angle Forming angle ABC. This same arc AC is forming angle ABC. And then what angle does it form on the circumference? Forms an angle of 60 degrees on the circumference. And then since it forms an angle of 60 degrees on the circumference, and this same arc AC is forming this angle ADC, then it means that angle ABC must be equal to angle ADC, which is what? 60 degrees. So it means that angle ADC must also be equal to 60 degrees. So that is that. I hope guys you are enjoying this video or this lesson. It's not circuit theorem is not difficult at all. In fact you will enjoy. You continue to see on this channel. You enjoy, because this channel, the purpose of this channel is to make you understand and to put an end to the memorizing of things. You don't have to be memorizing things. That when we are giving a question, you will not be able to solve. So you have to understand everything. Stop memorizing things and understand whatever you do. So thank you for watching, and see you in the next video. Don't forget to subscribe to my channel for more videos. Thank you for watching.